right, everybody, we are going to start with 4.5. So we are moving on to fractional exponents. Here is our warm-up. Go ahead, take a second, try to complete it on your own. So I know that anything to the power of 0 is 1, so my x to the power of 0 is going to go away, and my negative exponents are going to flip to the top. So our final answer would be 9x to the power of 7, y to the power of 3. Be very careful with that x to the power of 0. That power of 0 is only on the x. It is not on the 9. Don't get confused with that. We will do the same thing over here, so I know that y to the power of 0 will cancel. Our x to the power of 4 will have to go to the numerator, and we'll have to combine x to the power of 5 and x to the power of 4. So those will become x to the power of 9, and 7 over 14 will simplify to 1/2, or you could say just over 2, 1 x to the power of 9 over 2, both work. Okay, so we're moving on to fractional exponents, so we're going to take a second to talk about square roots. Square roots are an operation that asks what number multiplied by itself generates a given number. So square root of 64 is 8 because 8 times 8 equals 64. So the same number multiplied by itself. So if I go over here, I have some more examples. Square root of 4 is 2 because 2 times 2 is 4. Square root of 9 is 3. Square root of 16 is 4. So on and so on. So you can see here with these visual representations that those numbers are perfect squares, okay? So that's because it's like an 8 by 8 square. So with fractional exponents, we take the numerator, that becomes the power, and we take the denominator, and that becomes the root. So b to the power of 1/2 becomes the square root of b. B to the power of 1/3 becomes the cube root of b. B to the power of 1/4 becomes the fourth root of b. 25 to the power of 1/2 becomes the square root of 25, which is 5, because we can simplify that. And then 8 to the power of 1/3 becomes the cube root of 8, which is 2. So we'll go over this a little bit more. So what I do is I take the numerator, that goes to the outside, the denominator becomes the degree of the root. So 16 to the power of 1/4. The 1 goes to the power, stays the power. The 4 goes to the degree of the root. So we're asking for the fourth root of 16, all to the power of 1. So what number multiplied by itself 4 times is 16? It's actually going to be 2, because 2 times 2 times 2 times 2 is 16. So the fourth root of 16 would be 2, and 2 to the power of 1 is just 2. So we'll do this with 125 to the power of 1/3. So this becomes the cube root of 125 to the power of 1. So denominator becomes the degree of the root, and numerator becomes the exponent. So 125, the cube root of 125 is going to be 5, because 5 times 5 times 5 equals 125. And 5 to the power of 1 is just 5. All right, we're going to rewrite the expression with a fractional exponent. So I know that the number is 81. The numerator of the fraction must be 1, since it doesn't have a power other than 1. And since it's just a square root, that means it's going to be 1/2. 625 is going to be our base. The numerator is 1 again, because I don't see a power out there. And the denominator is going to be the 4, because that is the degree of the root symbol. Okay, we're going to simplify these expressions. We are going to multiply using our rules that we know with exponents. So we have a power to a power. That means I have to multiply, right? So this is going to be p to the power of 1/2 times 4. And we know when we multiply fractions, we multiply straight across. So that would be 4 over 2, or p squared. We're going to simplify the fraction. Same thing. This would be n to the power of 3 over 2 times 2 over 1. So we would get 6 over 2, which would simplify to n to the power of 3. So a lot of different things that you can do with fractional exponents. Just remember to make the denominator the degree of the root, and then simplify if possible.